Good day, everyone. I am Janita of Stella Matutina College of Education, currently pursuing B.Ed in Physical Science. Today, I'm gonna take a lesson on heat of Standard 9. In this lesson, we are going to learn about what is heat, effects of heat, transfer of heat, concepts of heat, specific heat capacity or thermal capacity, change of state, and latent heat. First, let's we see about what is heat. Heat is the energy that transfers from one body to another as a result of a difference in temperature. You can usually see or experience heat while cooking the food because when you heat a vessel, you can find the vessel being heated up and the heat gets transferred slowly to the handle. Now let's see about effects of heat. There are four different types of heat, that is expansion, change in state, change in temperature, and chemical change. Now let's see about expansion. When a heat is added to a substance, the molecules gain energy and vibrates and force other molecules apart. As a result, this expansion takes place. The best and most appropriate example is the railway tracks. As you travel through the train, you can observe the railway track has certain gaps in between them. Have you all thought why? It is because of this phenomena expansion. During the summer or during the heat weather, the molecules present in this metal gains the energy, gains the heat energy, and these molecules gets vibrated and force other molecules apart. So the expansion takes place. And due to prevent the accidents on the railway track, these gaps are present in between them. So once it gets expand, these gaps prevent them from getting those causes. Expansion is greater in liquids than solids, and it's maximum in gases. Now let's see about change in state. Solid becomes liquid and liquid becomes gases when heat is added. The reverse takes place when the heat is removed. The best and common example is the ice. When you remove the ice from the freezer, due to the atmosphere, to the heat atmosphere surrounded it, the solid definitely becomes a liquid and then the liquid becomes gas. But when you remove the heat, the reverse takes place. That is, the gas becomes a liquid and liquid becomes solid. Now let's see about change in temperature. When the heat energy is added to a substance, the kinetic energy of the particles increases, so the particles move at higher speed. Now let's see about the chemical change. Chemical reaction need heat to begin, and the heat determines the speed at which the reaction occurs. For example is when we cook food. When light the wood and it catches fire and the food particles become soft because of this heat energy. The heat is transferred from one place to another till their temperatures become equal. Heat transfer takes place when heat energy flows from an object with higher temperature to an object with lower temperature. The heat transfer takes place in three different ways. They are conduction, convection, and radiation. Now let's see about conduction. Conduction is the process of transfer of heat in solid from a region of higher temperature to a region of lower temperature without the actual movement of molecules is called the conduction. That is, liquid and gases conduct heat but very slowly. The conduction is a slow process where the metals are the good conductors of heat. Now, conduction in day-to-day life, that as I mentioned before, you can see metals are the good conductor of heat. Therefore, aluminium is used for making utensils to cook food very quickly. Next is mercury. Mercury is used in thermometers because it is also a very good conductor of heat. Due to mercury, we can able to test our temperatures with the help of a thermometer. When we wear the woolen clothes in the winter to keep ourselves warm, it is because the air, which is a bad conductor, does not allow our body heat to escape. Now let's see about what is convection. Convection means it's a flow of heat through a fluid from places of higher temperature to places of the lower temperature by the movement of the liquid itself. Convection in day-to-day life. That is the hot air balloon. In breezes, there are two different types. One is sea breeze. Sea breeze, in a sense, it is from sea to land. And the next one is the land breeze. That is from land to sea. Next is the winds. And then the chimney in our kitchen. Now let's see about radiation. Radiation is a type of heat transfer through the electromagnetic waves and needs no medium. It works in a vacuum like how the sun's heat reaches the earth. All the objects above 0 kelvins emit radiation which can be observed or reflected. Where radiation in day-to-day life, such as white or light, it is because white or light colored clothes are a good reflector of heat and they keep us cool during the summer season. Next, let's see about the base. Base, in a sense, the base of a cooking utensil, which is blackened because the black surface absorbs the more heat from the surroundings. Now let's see about the surface. Surface of the airplane is highly polished and it is because it helps to reflect most of the heat radiation from the sun. Now let's see the concept of temperature. Temperature is a degree of hotness or the coldness of a body. Hotter the body, higher is the temperature. And there are two concepts of temperature such as the unit of temperature and temperature scales. Now let's see the unit of temperature. The SI unit of temperature is Kelvin, which is denoted as K. But for our day-to-day life, it applies as Celsius, that is degrees C, is used. Temperature is measured with a thermometer. Now let's see about temperature of scales. There are three scales of temperature, that is Fahrenheit scale, Celsius or centigrade scale, Kelvin or absolute scale. Fahrenheit scale. Fahrenheit scale is 30 degree Fahrenheit and 212 degree Fahrenheit are the freezing point and the boiling point respectively. And it has an interval which has been divided into 180 parts. Now let's see about Celsius temperature scale. In Celsius scale, which is also known as centigrade scale, it is 0 degrees Celsius and 100 degrees Celsius are the freezing and the boiling point respectively. In this, the interval has been divided into 100 parts. The formula to convert a Celsius scale to a Fahrenheit scale is F is equal to 9 by 5 into C plus 32. The formula for converting a Fahrenheit scale into Celsius scale is C is equal to 5 by 9 into F minus 32. Now let's see about the absolute zero. It is the temperature at which a pressure and volume of a gas theoretically reaches zero is called the absolute zero. Now let's see about specific heat capacity. Specific heat capacity of a substance is defined as the amount of heat required to rise the temperature of 1 kg of the substance by 10 degrees Celsius or 1 Kelvin. The amount of heat energy absorbed or lost by a body is determined into three factors. They are mass of the body, change in temperature of the body, and nature of the material of the body. Now let's see about heat capacity or thermal capacity. Heat capacity or thermal capacity is commonly defined as the amount of heat energy required to raise the temperature of a body by 1 degree Celsius. And the heat capacity is commonly denoted by capital C. Now let's see about change of state. Change of state is a process of changing of a substance from one physical state to another at a definite temperature. As you can see in this picture, that is from solid to liquid, from liquid to gas. Likewise, from gas to liquid and liquid to solid. Or it can also be gas to solid and solid to gas. It is known as sublimation or deposition. Now let's see about melting to freezing. Melting or fusion is when a solid turns into a liquid by observing heat from the surroundings. The melting point is the temperature at which this occurs. Freezing is a reverse. Liquid turns into solid by releasing heat. The freezing point is a temperature where this happens. for water both occur at 0 degrees Celsius. Now let's see about boiling to condensation. Boiling or evaporation is when a liquid turns into vapor by absorbing the heat, where the boiling point is the temperature at which this happens. So, condensation is a reverse. That is, vapor turns into liquid by releasing heat at the condensation point. For example, for water, both occurs at 100 degrees Celsius. Now let's see about what is sublimation. In some solids like dry ice, iodine, frozen carbon dioxide, and naphthalene balls change directly from solid state to the gaseous state without becoming liquid. And this process in which a solid is converted to gaseous state and is called sublimation. Now let's see about the latent heat, which is the last topic of this lesson. The word latent means hidden. So latent heat means hidden heat or hidden energy. Latent heat is the amount of heat energy observed or released by a substance during a change in its physical state without any change in its temperature. In it, there are specific latent heat, where specific latent heat is the amount of heat energy observed or liberated by unit mass of a substance during change of state without causing any change in the temperature. Let's have a small recap on this chapter heat. In this chapter, we have learned about the transfer of heat, which consists of radiation, conduction, and convection. And we also learned about the change of state, which is melting, freezing, solidification, and sublimation. Last but not the least, we also learned about the measurement of heat energy, which consists of specific heat capacity, specific latent heat, and the thermal capacity. That's all for today. Thank you everyone for joining this lesson. I hope you all enjoyed and understood the concept of heat. Once again, thank you and have a nice day.